Welcome to the session number 19 from the playlist of moving charges and magnetism. The topic is the derivation of magnetic field at a point which is lying outside a current carrying conductor. So based on this topic, I have drawn here one diagram in which there is one cylindrical conductor as shown in this figure, which is carrying a uniform current I, and it is having a radius of capital R. And we have to find the magnetic field at this point P, which is at a distance of small r as shown in this figure. So in this derivation, we will be using the Ampere's Circuital law, about which we have studied in the session number 17. So as per the Ampere's Circuital law, the line integral of magnetic field around a closed loop or closed path, which is also called the Amperian loop, this is equal to mu naught times the net current which is passing through that closed loop or the closed path. So here I is the net current which is passing through the closed loop or the closed path. So in this question, what I have done that I have drawn one Amperian loop which is shown here with the help of a dotted line. So here in this case, the equation will be equal to, or you can say this Ampere's Circuital law can be mathematically defined by this equation, and here is I is what? It is the net current which is passing through this Amperian loop, and mu naught is what? It is the permeability of free space. So here this equation can further be written as, now here dl, now the summation of dl will be equal to the circumference of this Amperian loop, which will be equal to 2 pi r. So this equation can further be written as B dot, not this dl will be replaced by 2 pi r, and so from here the magnetic field at this point P, which is at a distance of small r from the axis of this current carrying conductor, this will be equal to mu naught I divided by 2 pi r. So from here we can see that the magnetic field is inversely proportional to r. That is, the magnetic field will decrease if the value of r increases, or the magnetic field will increase if the value of r decreases. So in the session number 20, I will be discussing one very simple question which will be based on this topic of Ampere's Circuital law, and on what we have studied in the session number 18 and 19. In the session number 18, we have derived the equation of the magnetic field at a point which was lying inside the current carrying conductor, and today we have derived the equation of the magnetic field at a point which is lying outside the current carrying conductor. So we will be using all those points in the session number 20, and we will try to solve one very simple numerical problem, but it will be based on this topic of Ampere's Circuital law. So till then, have a nice day. Bye.